String theory is a theoretical framework in physics that suggests that the universe is made up of tiny, one-dimensional, strings that vibrate at different frequencies. It is an attempt to unify all the fundamental forces of nature, including gravity, electromagnetism, and the strong and weak nuclear forces, into a single, consistent theory. The history of string theory can be traced back to the 1960s, when various physicists were attempting to reconcile quantum mechanics with general relativity, the theory of gravity proposed by Albert Einstein. The challenge was to find a way to describe gravity at the quantum scale, where it appeared to be much weaker than the other forces. In the 1970s, several theoretical physicists, including Yoichiro Nambu, Leonard Susskind, and Holger Beck-Nielsen, independently proposed the idea that particles were not point-like objects, but instead were made up of tiny, vibrating strings. This idea led to the development of string theory as we know it today. The key concept of string theory is that the universe is made up of tiny, one-dimensional strings that vibrate at different frequencies. These vibrations give rise to the different particles and forces that we observe in the universe. The different vibrations correspond to different energy levels, and particles are classified based on their energy and other properties. One of the most important features of string theory is that it requires the existence of extra dimensions beyond the 3 spatial dimensions and 1 temporal dimension that we experience. These extra dimensions are thought to be compactified, or curled up, at a very small scale, which is why we don't observe them directly. String theory has many implications for our understanding of the universe. One of the most important is that it offers a possible way to reconcile general relativity with quantum mechanics. It also offers the potential for unifying all the fundamental forces of nature into a single, consistent theory. However, because string theory is a theoretical framework, it is difficult to test directly through experiments. It has also been criticized for being unfalsifiable, meaning that it is impossible to prove or disprove through observations. In conclusion, string theory is a fascinating proposal that has the potential to revolutionize our understanding of the universe. While still theoretical, it has led to many important developments in theoretical physics and has inspired new ideas and research directions. However, much work remains to be done to fully understand the implications of string theory and to develop ways to test it through experiments. This physics tidbit is brought to you by Michael Kaminsky for a better world.